This video focuses on simplifying expressions involving division. When you simplify algebraic fractions, you deal with them as with normal fractions. So for example, I can simplify the numerator and the denominator by dividing both of them by 2. Okay, so 2 divided by 2 will give me 1, and then 4 divided by 2 will give me 2. So I have 1x over 2, and 1x can be written as simply x over 2. In the next one, I've got ab over 3a. Both of those, both the numerator and then the denominator can be divided by a. So a divided by a is 1, and a divided by a is 1. Okay, so it's 1b over 3 times 1, which is simply b over 3. In the next expression, we have a little bit more to do here. Okay, so let's look at the numbers first. I've got 3 and 12. So I'm going to ask myself, is there a number that goes into 3 and 12? There is. Okay, 3 goes into 3 and 12. So I'm going to divide the numerator and the denominator by 3. So 3 divided by 3 is 1, and 12 divided by 3 is 4. Okay, I can now look at the letters and see whether there's anything in common. Okay, and I can see that the numerator has y and then the denominator has y. So I can divide both the numerator and the denominator by y. Y divided by y is 1, and then y squared divided by 1, y will give me simply y. Okay, so I'm just going to cross out the power here, and I'll have only y left. Because remember that y squared means y times y. So one of those y's will cancel out. Okay, so now I have 1 times x times 1 over 4 times y. And I can simplify it, and that's just going to be x over 4y. Okay, again a bit more complex expression. So let's look at the numbers first. I've got 10 and 4. So what number goes into 10 and 4? So I can divide 10 and 4 by 2. Okay, that is the biggest number that goes into 10 and 4. So 10 divided by 2 is 5, and 4 divided by 2 is 2. Okay, I'm going to look at the letters now. Okay, both the numerator and the denominator have x, so I can cancel out x because x divided by x is 1 and x divided by x is 1. Okay, now the numerator has y but the denominator doesn't, so I can't simplify it. I'll move on to z. The numerator has z squared, the denominator has z, so I can divide the numerator and the denominator by z. Okay, so z divided by z is 1, and then z squared divided by z will give me z. So I'm going to cross out the power here. So now in the numerator I have 5z left, and then in the denominator I'll have 2 left. Okay, and the next one, this one involves powers. Okay, and it's very important to understand what those powers actually mean. So I'm going to write it out a little bit so you can actually see what happens. So x squared, that means x times x and then times y. Okay, and the denominator I have 3 times x times x times x. Okay, so I've got x multiplied by itself 3 times because in the denominator I've got x cubed. So we can now simplify. Okay, so I'm going to cross out x here and x here, so these two x's cancel out, and then another x and another x here, they cancel out as well, and there's nothing else that cancels out. So in the numerator I've got y left, and then in the denominator I've got 3x. And another one, again, quite complex. Okay, so let's do it step by step. So first I'm going to write it out again just like I did it in the previous example, so that it's easier for us to follow. Okay, so I've got 24 times a times b, because I've got b squared, and then times c. Okay, then I've got 9 times a times b times b times b. Okay, now I'm going to start cancelling out. So I've got 24 and 9. Is there a number that goes into 24 and 9? Well, there is, and the highest number, or in other words, the highest common factor of 24 and 9 is 3. So I can divide 24 and 9 by 3. 24 divided by 3 is 8, and 9 divided by 3 is 3. Okay, now I can see I can cancel a's, I can cancel one set of b's and then another set of b's, and that's it. Okay, I can't cancel anything else. So I've got 8c left in my numerator, and then 3ab left in my denominator.